Yes, friends. Today I am taking probability, which is very important topic here. Okay. Now, so far as this topic is concerned, it is so important that it cannot be, discarded. Okay, not discarded, but you can say cannot be avoided. Like in case of competitive examination, in case of any courses, like management courses, like engineering courses, probability is must a topic which is always there in every courses, not only in competitive examinations, mathematics for competitive examinations, but in case of BTech engineering students and tech students, or almost all the science students, they have to study this now probability, because probability has become a part and parcel of the statistical subject. Statistics is the branch of mathematics in which we study about the research, etc. Okay, statistical research, when data is collected and after that result is being found out or being calculated, estimated. So estimation of results based on these days, lot of political discussion is based on statistics, based on probability, that how much time the person can win, what the chances of the person's winning in the particular subject, in a particular topic here. This mathematician or this person can win this kind of award here or not, or this politician can win the election this year or not. So what are the chances of his chances winning a chance or getting a probability or probable. Okay, so probable is a word which is daily used, used in every conversation of a person's life. Okay, in today's conversation, probability, chance, this word is mostly used, cannot be avoided, let me tell you. Okay, and for example, the number of illustrative examples in conversation, or illustrations in case of conversation, he may come tomorrow, or there is a chance of rain today, it may rain today, it may rain tomorrow. Okay, so this is a probability, possibility. Okay, so the possibility, probability, the probability is a type of chance, a possibility of something which is doubtful, which is going to happen in the near future, which can happen in the near future, based on either the past result, or present experience, or past experience, or based on some theoretical analysis. Okay, so the probability is that subject, and probability, I have taken this probability now with introduction from beginning to the end. I'll take almost all topics concerned to the topic here. So this is very important topic, as students will demand that this topic cannot be avoided. This is to be taken in a vivid manner, in a broader manner, right? I'll take it in a broad manner. Every aspect of this I'll discuss. Okay, I will take from beginning to the end. So first I'm taking the contributors, the persons, the mathematicians, the scientists, the people who have contributed in the field of probability. That I am going to talk about. I have written down here on the board the names of these people. Okay, these mathematicians, from starting to the end, I'll talk about them. Okay, and some of the last one, 12th I think, or 11th one, their names are not coming in the camera, but I'll pronounce their names, and after that I'll discuss about them in the ahead topic ahead, the questions ahead. For example, first question is based on definition of probability. I have taken here, define the probability on the basis of these approaches. There are basically 4 approaches. Some people talk about some 3 basic approaches, but I talk about mostly the 4 basic approaches. Okay, those approaches, which are those approaches? First, classical approach. Okay, first and foremost thing is classical approach, or which is known as priori approach. What is priori approach? That its results are known in prior, or prior means we understand that what result can happen in the near future, what the result of this particular action. For example, if we toss a coin, okay, a coin is being thrown or a coin is being tossed. A coin is tossed, then it can have either a tail or a head. So probability of its is 1.2. If head appears or tail appears, then the chances of their appearance is 1.2, 1.2. This is priorly known to us. So okay, the game of chance, mostly tossing of a coin or throwing of a coin or a dice, or selecting a card out of a deck of cards. Okay, so selecting a deck of card or from a card from a deck of cards or from a pack of cards. So these kind of gambling questions, okay, initially they started, but nowadays probability has taken the most of the parts of one's life is involved probability, or is having probability of anything, probability of what is the chance of your going there, what is the chance of your winning this game, winning this award, winning this okay study, the subject, okay, what is your chances of mastery over the subject of yours, I mean what are your chances of mastery over the subject. So I mean that kind of things are there. So probability chances, what is chance of this, what is the it may happen, it may going to do this, or he is going to do this, or he can do this, right? The possibilities, the chances, these kind of questions are mostly asked in one's life. Okay, so probability is a word which cannot be avoided. That's why I have taken this topic, and this is very important topic so far as competitive examinations are concerned, so far as management subjects are concerned. In every management subject I have seen, I have taught a lot of times the same topic in a number of ways. Okay, there are a lot of things, mostly binomial distribution in of probability. What is binomial distribution? The topic is not coming in competitive examinations, but this is basically important for management courses, right? Binomial distribution, normal distribution, what is Poisson distribution, etc. So those distributions from binomial distribution is the topic based on probability. We will talk about that. Bayes theorem, very important. Condition probability, very important. Okay, almost all kinds of in competitive examinations, in management subject, in engineering courses, probability is the mostly talked about topic. That's why I have taken this in a vivid manner. I'll take this in number of lecture series. This is the first one lecture series I'm talking about. Let me now talk about who are the contributors of this field. After that I'll take question number 1, which is the definition of probability based on 4 approaches. The first approach, which is classical approach, the oldest one, classical approach, which is known as priori approach also. Priori means because its results are known to us. There are definite results going to happen. Okay, which is based on equally likely events or equally likely chances. Okay, so that we'll talk about. Then second is empirical or experimental or empirical or posteriori approach. Posteriori approach is very important. What kind of the field of this discussion is the oldest classical approach I'll talk about. This is very important because definition is mostly based on that. And then the last one, the fourth one I'll talk about, which is very important because that is known as axiomatic approach. Axiomatic approach means based on 3 axioms or theorems, or you may say the theories or the basic axioms. So 3 axioms are there. The fourth definition of probability, which is very important. This is axiomatic approach to probability. Axiomatic approach to probability, which is the last one. In 1933 it was established. Okay, so in 1933 this this basic definition of probability, basic approach to probability came up. Okay, so this I'll talk about finally, the fourth definition. Then the third one is subjective or personalistic approach. This was introduced in 1926, and I'll talk about that. Who are the contributors? That I'll talk about it. Just okay, I'll read them and then I'll just rub this left hand side, the names of these people, contributors, the mathematicians, which are very important because their contribution cannot be avoided, we cannot say that without their contributions this subject of probability is possible. Okay, I know that since time immemorial all people are understanding that word chance. It may happen, every person is thinking about future activities. Okay, it may happen, may not happen, is going to happen tomorrow, or it may rain today. It may the person who has climbed upon the highest building and is going to die, he may die or may not die. He's going to the person is going to be murdered because he has abused that person, so may not be murdered. So that kind of possibilities and possible topic is included in probability. Yes, that are the. Now the first topic, classical approach. Then second is empirical or experimental or posteriori second approach. Third approach is subjective or personalistic approach, and fourth is axiomatic approach. Now let me talk about the contributors. What are the contributors of probability? The subject probability, there are number of contributors in the field of this. Okay, so what are the contributors? First, contributions in the field of probability. Contribution in the field, contributors or contributions in the field of probability. So who are the contributors? First contributor, starting with Girolamo, name is Girolamo Cardano, Girolamo Cardano, 1501 to 1576. Okay, during this period, an Italian, he was an Italian. Okay, an Italian. His book on games of chance, published in 1663 after his death. He died in 1576, but his book was published in 1663 after 100 of years. I mean, about 90 years, right? So about 87 years, his book was published after his death. So, and in this book, he has written a book of chance. What is the name? Games of Chance. This book he introduced. I mean, he wrote down a book named as Games of Chance. Games of chance, based on dice. I mean, throwing of a dice or throwing of a coin, or tossing of a coin or throwing of a dice, and selecting it taking it or selecting a card from a pack of cards. All right. So all these questions based on these kind of possibilities, gambling type of questions. This is games of chance. Games of chance. Okay. So based on all these basic things, he has introduced this. So this was the person is first introduced to the games of the subject of probability. Subject of probability was introduced by, initially he thought about something, he wrote down a book, Games of Chance. His name was Girolamo Cardano, Girolamo Cardano, okay, 1501 to 1576, in Italian. So initiators, these two people were from Italy. Second is Galileo 1564 to 1642, an Italian. He attempted to quantitative way to theory of dice in gambling. In gambling theory of dice, he gave some quantitative methods, solution of quantity. He found out the quantity. Quantity means he gave some mathematical form of this game of chance. So these first two people were Italians, Italian mathematicians. Galileo, very famous person, famous mathematician. His name is not required so much introduction. He is already well famous. Okay. The question is, these two Italian people, they introduced the probability. They thought about probability. Probability is undoubtedly it was there, but they were the introducers to this particular subject in the field of mathematics. Right. Now come to the point. So Girolamo Cardano, Italian, 1501 to 1576, and then Galileo 1564. So mid 60s you may say, 1501 to 1576. It is in 16th century. In 16th century, with the beginning of probability, right? Probability was introduced in the form of games of chance by this first person, Girolamo Cardano. His book was published in 1663 after his death. Then Galileo 1564 to 1642, and Italian again, he attempted to quantitative way of theory of dice in gambling. So he gave mathematical form or quantitative form to the theory of gambling. Theory of gambling. Okay, so theory of dice or in gambling. Theory of dice in gambling. This is the second question. Both were Italians. Then the third point, in 1623 to 62, these two people gave the mathematical, actually their contribution is the beginning of the basic subject of probability. What is the basic subject? These two French people, French mathematicians, His name was B. Pascal. B. Pascal, a French mathematician, and Pierre de Fermat. Pierre de Fermat, 1601 to 65, and his B. Pascal was 1623 to 62. Both were French mathematicians. These two people's contribution in the field of mathematics was the beginning of mathematical form of this. Okay, he just introduced the second Italian. He gave mathematical form, I mean quantitative form. He thought about that, but these two people, French mathematicians, they gave the mathematical form to the games of chance. Okay, or they thought about that how this can be introduced in the as a subject in the field of statistics or in the field of mathematics. So statistical subject is introduced by these two French mathematicians. Their contribution in the field of this is the beginning of the subject of probability, right? Or subject as a probability, or probability as a subject in the statistics. Now let me take, after these two French mathematicians, Jacques Bernoulli, a Swiss mathematician, he studied for 2 decades. His contribution for 2 decades, he studied the same subject, statistics. Okay, for 2 decades. Bernoulli, J. Bernoulli, his name is Jacques Bernoulli, J. Bernoulli or Jacques Bernoulli. Jacques Bernoulli, 1654 to 1705. 1705. So Jacques Bernoulli or J. Bernoulli, this is known as Swiss mathematician. He studied for 2 decades the same subject, and he gave number of formats. His theorems are so much known. We'll talk about them. Okay, and then De Moivre, he was the doctrine of chances. The doctrine of chances, De Moivre's theorem, or De Moivre wrote a book, Doctrine of Chances, contributed a lot. So De Moivre and Jacques Bernoulli, these two people contributed a lot in the field of probability. Okay, so their contributions, the person who is studying or doing the research in statistics or in probability, he can go through all the subjects written by these two people, Jacques Bernoulli and De Moivre. De Moivre's theorem is well known, we know about. Bernoulli also. Okay, these two people's contributions in the field of mathematics, in the field of scientific subject, I mean mostly mathematics or statistics. Initially it was only mathematics, but now it is statistics subject. Okay, so their contributions are Swiss mathematicians. The doctrine of chances by De Moivre and J. Bernoulli. He studied for 2 decades. A lot of contribution by him is unforgettable. Okay, so these two people, then so 5th and 6th people, I mean their contributions up to 6 we have discussed now. Then the Bayes theorem. Bayes theorem we will discuss about. He gave inverse probability. The definition of inverse probability. What is inverse probability? He gave this first time. So Bayes, very important person. I mean his contribution cannot be forgotten. Now cannot be forgotten. So 1702 to 61, mid 70s. In mid 70s, up to mid 70s, he contributed a lot. Bayes theorem we will discuss about. There is a separate lecture series. I'll discuss about this also. Okay, on Bayes theorem. What is Bayes theorem? He gave inverse probability. Definition of inverse probability. What is inverse probability? We'll talk about that also. Okay, so Bayes theorem or Bayes, 1702 to 61, gave inverse probability. This is very important. Inverse probability. He gave the definition of inverse probability. So his contribution is unforgettable. Then Pierre-Simon Laplace. Now this person, Laplace, he gave the beginning of classic definition, prior definition, the first one. The classical or priori approach to probability. This is very important. Okay, from this person, Pierre-Simon Laplace, 8th one. Pierre-Simon Laplace, 1749, mid 70 or 18th century we may say, in 1749 to 1827. So in mid 70s or 18th century, 1765 to 1749 to 1827. Theory of analytical probability. This important book he wrote down, Theory of Analytical Probability. analytical probability. Theory of analytical probability, he gave the basic definition in the beginning, classical definition, which is the beginning of this, the definition of probability. We'll talk about this because this is very important. So Pierre-Simon Laplace, 1749 to 1827, his contribution is in the first field of approach of definition of probability. So first he introduced what is the classical definition of prior definition, prior approach, priori approach. This is priori approach. Why priori approach? We'll talk about. Okay, so his contribution, Laplace, Simon Laplace, name is Pierre-Simon Laplace. So Pierre-Simon, 8th question onwards, their definitions are present today, being discussed. Okay, they were the introducers, but these people have contributed a lot. Finally, their contribution is still regarded today. We study about what is definition of classic definition given by Pierre-Simon Laplace, 1749 to 1827, theory of analytical probability. Then R.A. Fisher. Then second approach, which is known as empirical approach or posteriori approach. Second one, post-empirical or experimental, empirical or posteriori. Posteriori, we will talk about that. What is posteriori approach? This was given by R.A. Fisher and von Mises and von Mises or von Mises. Okay, R.A. Fisher and von Mises, 9th one. R.A. Fisher and von Mises, they introduced empirical approach or experimental approach or posteriori approach to the definition of probability. This is important. We will talk about that. What is this empirical approach and why this R.A. Fisher and von Mises gave that. What is their theory? What is this approach? We will talk about this in detail. But in the first question, we will discuss about this empirical approach. This R.A. Fisher and von Mises, unforgettable because they gave the second approach of definition of probability. Then Frank Ramsey in 1926, the second last approach, this known as subjective approach. Third one, subjective approach or personalistic approach, given by Frank Ramsey in 1926. The foundations of mathematics. He wrote a book, Foundations of Mathematics, in which he has introduced the third subjective approach to subjective approaches known as personalistic approach also. Personalistic approach to definition of probability. So how probability is defined in personalistic way, I'll talk about that. What is personalistic way, what is subjective way, given by Ramsey. Okay, this is Frank Ramsey. He was a French, I think. So Frank Ramsey, 1926, and 1933 the last one. And A. Markov and A. N. Kolmov. Okay, and these two Russian mathematicians. Last one, A. Markov, 1856 to 1922. 11th one, A. Markov, 1856 to 1922, and the 12th one is not visible in the camera, but let me read his name, very important. A. N. Kolmogorov, Kolmog, K-O-L-O-M, Gorov, G-O-R-O-V, A. N. Kolmogorov, Kolmog, K-O-L-M-O-G-O-R-O-V, Kolmogorov. He wrote a book in 1933, and in 1933 he gave this approach, axiomatic approach to definition of probability, which is nowadays popular, based on 3 axioms. I'll talk about them. Very important definition. And the last one, this A. N. Kolmogorov and A. Markov, both were Russian mathematicians. Okay, A. Markov, 1856 to 1922, and A. N. Kolmogorov, he axiomized the theory of probability. Okay, theory of probability, and in 1821 to 94, A. Markov, 1821 to 1904, the Russian mathematician like Chebyshev, This Chebyshev was in 1821 to 94. Chebyshev, 1821 to 94, and A. Markov in 1856 to 1922, and A. N. Kolmogorov. This is Kolmogorov. Okay, A. N. Kolmogorov. A. N. Kolmogorov's name is very much famous because he is the last contributor in 1933. He gave this theory of axiomatic approach to definition of probability. Okay, so this axiomatic approach, and starting from games of chance, the first one, starting from games of chance, right, to the today's definition of probability, which is known as axiomatic approach. Okay, up to the axiomatic approach, all these different contributions by different mathematicians are unforgettable. They have given the present day form of statistics or present day form of probability. Now, present day form of probability is we cannot say that it can be separated from statistics, because statistics and probability both are inseparable. They cannot be separated from each other because their definition is whenever we talk about statistics, then probability is null. Then without probability there is no statistics, because we say that what are the statistics for political event, what is going to happen in the politics today. Okay, what is the exit poll? What exit polls say? Exit polls are based on all these probability. Okay, probability means chances. What are the chances of winning of the particular candidate? That chances, probability is the game of chance. So we'll talk about this. Now I'll rub all these names, contributors, but the last fourth one, which is A. N. Kolmogorov, is very important. Okay, in 1933, A. N. Kolmogorov wrote a book. He gave this axiomatic approach to probability. What is the axiomatic approach to definition of probability? I'll talk about. But the first one, classical approach, or known as priori approach, I'll talk about that. That was given by Laplace. Eighth one, Pierre-Simon Laplace. So Pierre-Simon Laplace, R.A. Fisher and von Mises, Frank Ramsey, and A. N. Kolmogorov. These four people, the last one, okay, mostly their major contributions, the present day four approaches to definitions of probability are unforgettable. They are the last people who have contributed to the field of statistics or field of probability. Okay, now let me rub these names of these people, these contributors, because they are unforgettable. We have not to forget their names, because they are basic people. They are contributing. Their contribution is in the field of probability. So if we want to study probability, then we have to know about their contributions. Alright, so this is what we have to talk about. Rub this. So all these people, they are the contributors basically. Now let me rub their names. So A. N. Kolmogorov, the last one. Okay, the chance of probability today, he has become one of the tools of statistics. The probability is nowadays the basic subject of in the field of study, in the field of research. So without statistics, we cannot go on. Now let me rub these. After that, I'll solve these questions. I'll take the questions there. I'll take the questions here then. Okay. So I'm sorry, duster is not proper one. So what are the definitions? What are the approaches? The first question, define the probability on the basis of these approaches. First approach is classical or post or priori approach. I'll talk about that, but before that, let me clean this board properly. Okay, so these statisticians or mathematicians' contribution is unforgettable. That's why I've taken them. Their contribution is unavoidable. That's why I haven't written their names. Otherwise, I could just mention those four people, the last one, in case of the first question. But from the first one,